So let's try to answer this question by applying the Newton's second law of motion. What is the net force that acts on a 20-kilogram object accelerating at 5 meter per second square? So we're solving for the net force. First, let's try to identify the given. So what are the given? We have here mass, that is 20 kilogram, and we also have acceleration, which is 5 meter per second square. And we're looking for the net force. So applying the Newton's second law of motion, remember we have net force is equal to mass times acceleration. Therefore, we have mass, which is 20 kilogram, times the acceleration, which is 5 meter per second square. Multiplying it, we have 20 times 5, we have 100 Newton. So this is now the net force that we're solving for. Let's try another one. Okay. What is the net force that acts on a 50 kilogram object accelerating at 10 meter per second square? Let's write the given. We have the given mass as 50 kilogram and acceleration, which is 10 meter per second square. And we're looking for the net force. Applying Newton's second law of motion, we have net force is equal to mass times acceleration. Mass is 50 kilogram. Acceleration is 10 meter per second square. So 50 times 10 is 500 Newton. So this is not the net force. Okay, let's try to answer this question. Drum drawer is being pushed by a horizontal force of 600 Newton. If the drawer accelerates by 5 meter per second, how much frictional force is present between the surfaces in contact? So, the first thing that you need to do here is to identify all the given. So, we have here the given. So, first, we have a mass, which is 100 kilogram, and is being pushed by a horizontal force of 600 Newton. So meaning to say, we have the force applied. We have the force applied, which is 600 Newton. And if the drawer accelerates, so we have a given acceleration, which is 5 meter per second square. The question is how much frictional force is present between the surface in contact. So we are solving for the frictional force, meaning to say the force opposes the motion. So how are we going to solve that? But first, let's draw the free body diagram. So assuming this is now the box, the drawer that is being, again in free body diagram, kindly write all the force acting on an object. So we have here the force applied, which is 600 Newton. Now, the one that we're looking for is this one, the frictional force, the one that opposes the motion. So what is the value? So how are we going to solve for the frictional force with this given, with this only given? Okay, this is now the application of Newton's second law of motion. So remember, the Newton's second law of equation is net force is equal to mass times acceleration. Now, if we find the net force, later on, we will solve for the friction. Or we can solve for the friction. In what way? So, we have here the given mass, which is 100 kilogram. And we have here a given acceleration, which is 5 meter per second square. So let's compute 100 times 5. We have 500 Newton. So this is now the net force, meaning to say this is now the total force acting on an object. However, in order to check whether this is really the total force acting on an object, we need to find, of course, for the frictional force. But how are we going to solve for the frictional force, knowing that we have already the force applied and we already compute for the net force? Remember how to compute for the net force by adding all the force acting on an object. So we have here net force equals to the total force acting on an object. So what are the total force acting on an object? We have the force applied that is to the right, therefore it is 600, it is positive. And also we have friction that opposes the motion of force applied, so it is negative. This is not the equation. Since we all know the value of net force, which is 500 Newton, or kindly substitute it, equals the force applied, which is 600 Newton, and we don't know the value of friction, which is the one that we're looking for. So let's transpose 600 Newton on the left side. So by transposing it, it will become like this. 500 Newton minus 600 Newton equals negative F. Okay, 500 minus 600, negative 100 Newton equals negative F, or negative friction, divided by negative 1. Okay, so negative 1 is being cancelled, negative, negative. So we have here 100 Newton equals F. So therefore, the magnitude of the friction, that the one that we're looking for, is 100 Newton. So this is now the answer that we're looking for.